When I podcast or record voiceovers, I use a Shure SM7B microphone into a Scarlett Focusrite 18i8. But recently, I wanted to get more gain and processing on it before going into Adobe Audition. After some research, I landed on the dbx 286s microphone preamp and processor. In this video, I'm going to review it and walk through what cables you need to use it, what each of the dials on it do, what to set them all to, and any pros and cons I've seen while using this. Let's start on the back. First, you have the AC power plug, but no on-off switch. So if you plug this in, it's always on. Then there are 3 input and output options. I use a regular XLR cable to go from my Shure SM7B to the mic input on my dbx 286s. Then I use a 3-foot XLR male to 1/4-inch TRS male cable to go from the line output jack on the dbx 286s to an XLR input on my Focusrite 18i8. There's also a line input jack and an insert jack that you'd use for an effects loop or a separate mic preamp, but remember, you only have one output on this device. On the front, you'll want to move from left to right as you set this up, so let's start with the mic preamp section. For the gain knob, talk into your microphone or play whatever other input device you're using, like a guitar, and watch the lights while you turn the knob until you're consistently hitting the -10 level. You don't really want to hit 0, and you definitely don't want to hit clip. For the Shure SM7B, I have my gain set up pretty much all the way. For the 48-volt power button, if you don't see any levels, it's probably because you're using a condenser mic that needs phantom power. So be sure to turn this on. For my dynamic mic, I don't need this, so I have it set to off. For the 80 Hz bypass, I leave this off because it gives you less dynamic range, but if you're in a room with a hum below that frequency, experiment with turning it on. Then you have the process bypass button. If you turn this on, it essentially disables everything to the right, the compressor, the de-esser, the enhancer, and gate that we're about to set up. You'd really only use this for making, a comparison between the processed and unprocessed settings, or using this only as a dedicated preamp. We'll leave it off and we'll move along. So next up, we have the compressor. In the compressor settings, you have drive and density. Drive determines the gain reduction signal. Turning this clockwise will increase the input signal, which increases the amount of gain reduction. Turning it fully counterclockwise to off allows the compressor to pass all signals unattenuated, basically bypassing this compressor section. The density knob controls the release time of the compressor. At 0, you get a slow release for smooth compression, which you'd use to gate out noise present behind your vocals or your acoustic instruments. At 10, you get a fast or tight release, which would be used on a kick or snare drum. Next, you see the gain reduction meter in decibels. The meter shows you the true peak gain reduction in decibels. If the red LED at the far left lights up, no further gain reduction is available. Next, you have the de-esser. This starts with frequency, and this control sets the high pass frequency of the filter used in the de-esser to help remove the sound when talking. 4 to 8 kilohertz is best for when you're doing vocal processing. Then you have threshold. The threshold sets the sensitivity of the de-esser as a percentage of the average input level. LEDs light up for 1 dB and 6 dB when active. Now on to the final section with the enhancer. The first enhancer knob is for LF detail, or low frequency. This enhancer control applies a boost to 80 and 250 Hz without making the bass sound too muddy or boomy. The high frequency detail enhancer works to add definition and crispness to vocals, guitars, and other instruments. It's basically a little bit of magic for making things sound better at the top end. Then you have the expander and gate controls. First up is the threshold control, which determines when the expander and gate will fully open up and allow the input signal to pass through to output. Turning it fully counterclockwise turns it off completely. I have mine at about 30 dB, so anything below 30 isn't passed through to the output and works as a bit of a noise gate. The LED lights show up when it is on and off. So as I'm talking here, you can see that it turns green. When I'm not talking, it turns red, and no signal is pushed through the device. The expansion ratio control controls the expansion and attenuation applied to the input signal once it's below the threshold we set. So if it's below 30 dBs, what's the ratio it's going to apply to that signal? Lower thresholds like 1:1 or 2:1 are better for slower material like vocals. Higher thresholds up to 10:1 are for very fast inputs like percussion. So you've made it through the whole device, and I could have just told you where I set all my levels, but unless you're using the exact same equipment in a similar environment as me, your settings are going to need to be a little different. So I wanted to teach you what each of these knobs and buttons do. Now you can tweak the device a little bit to your own needs. To wrap up, I'm happy with the results I'm getting from this to boost the gain of my microphone, plus add a simple compressor, gate, and de-esser. It would be great if you could run multiple mics in and out using the same settings without having to buy an additional one for each microphone or input you want to use, but I understand the limitations technically and hardware-wise of that. And unless you're going to rack mount this with other audio gear, it's quite large to put on a desk or hide in a cabinet or drawer. If you have questions about this setup or the dbx 286, leave them in the comments below, and please subscribe to our YouTube channel for more video and audio gear reviews, as well as setup tutorials like the ones I made for the Focusrite Solo 2i2 and 18i8. And until next time, remember, if you're going to do it, might as well do it on video.